Yes, two-conductor BX cable with ground can be sleeved into polyvinyl chloride or PVC pipe and then into the circuit breaker panel, provided that certain conditions are met. Firstly, the polyvinyl chloride pipe must be properly sized. The polyvinyl chloride pipe must be large enough to accommodate the BX cable and its fittings. The minimum recommended trade size for two-conductor BX with ground is 1/2 inch. Secondly, protect the BX cable from moisture. The polyvinyl chloride pipe must be sealed to prevent moisture from entering the BX cable. You can use polyvinyl chloride couplings or adapters with gaskets to create a watertight seal. Thirdly, support the BX cable properly. The BX cable must be properly supported within the polyvinyl chloride pipe. Cable supports or straps can be used to hold the cable in place. Fourthly, install a grounding conductor. If the BX cable does not have a grounding conductor, one must be installed before sleeving it into the polyvinyl chloride pipe. The grounding conductor must be sized according to the National Electrical Code, or NEC. Fifthly, keep the total length of polyvinyl chloride pipe short. The total length of polyvinyl chloride pipe used to sleeve the BX cable should not exceed 3 feet. This is because the polyvinyl chloride pipe can act as a conduit, and conduit runs longer than 3 feet require pulling permits and inspections in most jurisdictions. Here are the steps on how to sleeve BX cable into polyvinyl chloride pipe. 1. Cut the polyvinyl chloride pipe to the desired length. 2. Dever the edges of the polyvinyl chloride pipe. 3. Apply a sealant to the inside of the polyvinyl chloride pipe. 4. Insert the BX cable into the polyvinyl chloride pipe. 5. Secure the BX cable in place using cable supports or straps. 6. Install a grounding conductor if necessary. 7. Seal the ends of the polyvinyl chloride pipe with polyvinyl chloride couplings or adapters with gaskets. 8. Secure the polyvinyl chloride pipe to the circuit breaker panel using appropriate fasteners. It's important to follow all applicable electrical codes and regulations when installing BX cable. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to do the job. Let's delve into each of these points with more detail to ensure a complete understanding of sleeving BX cable into polyvinyl chloride pipe. When selecting the polyvinyl chloride pipe size, remember that overcrowding can lead to overheating and potential damage to the cable. A 1/2 inch trade size is generally sufficient for a two-conductor BX cable with ground, but it's crucial to verify that the internal diameter of the pipe allows the cable to pass through smoothly without excessive force. If the cable feels too tight, consider using a larger pipe size. Protecting the BX cable from moisture is paramount, especially in damp or humid environments. Moisture can corrode the metallic sheath of the BX cable and compromise its insulation, leading to short circuits or ground faults. Using polyvinyl chloride couplings or adapters with gaskets creates a watertight seal, preventing moisture from entering the pipe. Apply polyvinyl chloride cement to the joints for added protection. Consider using heat shrink tubing around the BX cable connectors inside the polyvinyl chloride pipe for additional moisture protection. Proper support of the BX cable within the polyvinyl chloride pipe prevents sagging, strain, and potential damage to the cable. Cable supports or straps should be installed at regular intervals, typically every 12 to 18 inches, to hold the cable securely in place. Use cable ties to bundle the BX cable and secure it to the support straps. Ensure that the support straps do not pinch or damage the cable's outer jacket. The grounding conductor is a critical safety feature that provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. If the BX cable does not have a grounding conductor, a separate grounding wire must be installed and connected to the circuit breaker panel's grounding bus bar. The size of the grounding conductor must comply with the National Electrical Code Table 250.122, which specifies the minimum size of grounding conductors based on the rating of the overcurrent protection device. For example, a 15 amp or 20 amp circuit requires a 14 American wire gauge copper grounding conductor. Keeping the length of the polyvinyl chloride pipe short, no more than 3 feet, is important because longer runs of conduit require additional support, bonding, and grounding measures to comply with the National Electrical Code. The polyvinyl chloride pipe can act as a conduit, and conduit runs longer than 3 feet are subject to specific requirements outlined in the National Electrical Code Articles 300 and 352. These requirements include proper support bonding to the grounding system and the use of approved fittings. Exceeding the 3-foot limit without complying with these requirements can result in code violations and potential safety hazards. Now let's go through the steps of sleeving BX cable into polyvinyl chloride pipe in more detail. Step 1. Cutting the polyvinyl chloride pipe to the desired length. Use a polyvinyl chloride pipe cutter or a fine-toothed saw to cut the polyvinyl chloride pipe to the required length. Ensure that the cut is straight and clean to facilitate proper joining. Measure the distance between the circuit breaker panel and the point where the BX cable enters the polyvinyl chloride pipe, adding a few inches for connection. Step 2. Deburring the edges of the polyvinyl chloride pipe. Use a deburring tool or a utility knife to remove any sharp edges or burrs from the cut ends of the polyvinyl chloride pipe. Deburring prevents damage to the BX cable's outer jacket during installation. Step 3. Applying a sealant to the inside of the polyvinyl chloride pipe. Apply a thin layer of polyvinyl chloride cement to the inside of the polyvinyl chloride pipe at the points where the BX cable will pass through. This helps to create a watertight seal and prevent moisture from entering the pipe. Step 4. Inserting the BX cable into the polyvinyl chloride pipe. Carefully insert the BX cable into the polyvinyl chloride pipe, ensuring that it passes through smoothly without excessive force. Avoid twisting or kinking the cable during insertion. Step 5. Securing the BX cable in place using cable supports or straps. Install cable supports or straps at regular intervals along the length of the polyvinyl chloride pipe to hold the BX cable securely in place. Use cable ties to bundle the BX cable and secure it to the support straps. Step 6. Installing a grounding conductor if necessary. If the BX cable does not have a grounding conductor, install a separate grounding wire and connect it to the circuit breaker panel's grounding busbar. Ensure that the grounding conductor is properly sized according to the National Electrical Code Table 250.122. Step 7. Sealing the ends of the polyvinyl chloride pipe with polyvinyl chloride couplings or adapters with gaskets. Install polyvinyl chloride couplings or adapters with gaskets at both ends of the polyvinyl chloride pipe to create a watertight seal. Apply polyvinyl chloride cement to the joints for added protection. Step 8. Securing the polyvinyl chloride pipe to the circuit breaker panel using appropriate fasteners. Use appropriate fasteners, such as conduit clamps or straps, to secure the polyvinyl chloride pipe to the circuit breaker panel. Ensure that the fasteners are properly sized and installed to provide a secure and stable connection. Always follow applicable electrical codes and regulations when installing BX cable. The National Electrical Code provides detailed requirements for electrical wiring, including the installation of BX cable and conduit. Familiarize yourself with these requirements and ensure that your installation complies with all applicable codes. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to do the job. Electrical work can be dangerous, and improper installation can result in electrical shock, fire, or other hazards. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. Additional considerations and best practices. Before starting any electrical work, always turn off the power to the circuit at the circuit breaker panel. Use a voltage tester to verify that the circuit is energized before proceeding. Wear appropriate personal protective equipment, such as safety glasses and gloves, to protect yourself from electrical hazards. Use only approved electrical materials and equipment that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. Follow the manufacturer's instructions for all electrical materials and equipment. Never overload electrical circuits. Ensure that the total load in the circuit does not exceed the rating of the circuit breaker. If you are unsure about any aspect of electrical wiring, consult with a qualified electrician. Regular inspection and maintenance of electrical systems are essential for ensuring safety and reliability. Inspect electrical wiring, outlets, and switches for signs of damage or wear. Replace any damaged or worn components promptly. Test ground fault circuit interrupters, or GFCIs regularly to ensure that they are functioning properly. Keep electrical panels and equipment clean and free from dust and debris. In addition to the specific steps outlined above, there are some general best practices to keep in mind when working with BX cable and polyvinyl chloride conduits. Always handle BX cable with care to avoid damaging the outer jacket or insulation. Use appropriate tools for cutting and stripping BX cable. Avoid using excessive force, which can damage the cable. When bending BX cable, use a cable bender to avoid kinking or damaging the cable. Support BX cable properly to prevent sagging and strain. Use cable supports or straps at regular intervals, typically every 4.5 feet for horizontal runs and every 6 feet for vertical runs. Protect BX cable from physical damage. Run cable through walls, floors, or ceilings to protect it from impact or abrasion. Use conduit or other protective measures when BX cable is exposed to physical damage. Ground BX cable properly to prevent electrical shock. Connect the grounding conductor to the circuit breaker panel's grounding busbar and to any metal enclosures or equipment that the cable passes through. Inspect BX cable regularly for signs of damage or wear. Replace any damaged or worn cable promptly. By following these steps and best practices, you can ensure a safe and code-compliant installation of BX cable sleeved into polyvinyl chloride pipe. However, it is important to remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians and other electrical professionals to be familiar with the NEC and to follow its requirements when performing electrical work. The NEC is divided into chapters, articles, and sections. Chapter 1 covers general requirements such as definitions, scope, and organization. Chapter 2 covers wiring and protection, including wiring methods, overcurrent protection, and grounding. Chapter 3 covers wiring methods and materials, including conduit cable and raceways. Chapter 4 covers equipment for general use, including appliances, motors, and lighting. Chapter 5 covers special occupancies, such as hazardous locations, healthcare facilities, and swimming pools. Chapter 6 covers special equipment, such as elevators, escalators, and electric signs. Chapter 7 covers special conditions such as emergency systems, fire alarm systems, and communications systems. Chapter 8 covers communications systems such as telephone, data, and cable television. Chapter 9 contains tables and examples for use with the NEC. The NEC is a complex document, and it can be challenging to navigate and understand. However, it is essential for electrical professionals to be familiar with the NEC and to follow its requirements when performing electrical work. There are many resources available to help electrical professionals learn about the NEC, including training courses, seminars, and publications. The National Fire Protection Association also offers a certification program for electrical inspectors. In addition to the NEC, there may be local electrical codes and regulations that apply to electrical work in a specific jurisdiction. It is important to check with the local authorities to determine the applicable codes and regulations before starting any electrical work. Electrical safety is paramount, and it is essential to take precautions to protect yourself and others from electrical hazards. Always turn off the power to the circuit before working on electrical wiring or equipment. Use a voltage tester to verify that the circuit is de-energized before proceeding. Wear appropriate personal protective equipment, such as safety glasses and gloves, to protect yourself from electrical shock or burns. Use only approved electrical materials and equipment that are listed by a recognized testing laboratory. Follow the manufacturer's instructions for all electrical materials and equipment. Never overload electrical circuits. Ensure that the total load on the circuit does not exceed the rating of the circuit breaker. If you are unsure about any aspect of electrical wiring, consult with a qualified electrician. Regular inspection and maintenance of electrical systems are essential for ensuring safety and reliability. Inspect electrical wiring outlets and switches for signs of damage or wear. Replace any damaged or worn components promptly. Test ground fault circuit interrupters or GFCIs regularly to ensure that they are functioning properly. Keep electrical panels and equipment clean and free from dust and debris. By following these safety precautions and best practices, you can minimize the risk of electrical hazards and ensure a safe and reliable electrical system. Sleeving BX cable into polyvinyl chloride pipe is a common practice in electrical wiring, but it is important to follow the proper procedures and safety precautions to ensure safe and code-compliant installation. By understanding the requirements of the National Electrical Code and following the steps outlined above, you can safely and effectively sleeve BX cable into polyvinyl chloride pipe. Always remember, if you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to do the job. Electrical work can be dangerous, and improper installation can result in electrical shock, fire, or other hazards.